Welcome to Spelling Bee Ninja, where we ignite your curiosity with fascinating educational content. Join our community of lifelong learners and uncover the wonders of science with us. Don't forget to subscribe for more inspiring lessons that make learning fun and engaging. Today, we are diving into the life and groundbreaking discoveries of one of history's most influential scientists, Isaac Newton. Let's explore how his work on gravity, motion, and mathematics revolutionized our understanding of the physical world. Isaac Newton, born on Christmas Day in 1642, was more than just a mathematician. He was a true pioneer whose ideas shaped our understanding of the universe. His illustrious career began in the wake of the Renaissance, a time when a wave of scientific inquiry started to flourish. He is perhaps best known for his work in classical mechanics, particularly articulated in his seminal work, Philosophiae Naturalis Principia Mathematica, commonly referred to as the Principia, published in 1687. This remarkable book introduced the world to Newton's three laws of motion, laying down the fundamental principles of physics that would dominate for centuries. The first law, often called the law of inertia, states that an object will remain at rest or in uniform motion unless acted on by an external force. This concept changed how we approach the understanding of motion, moving from a purely philosophical debate to a mathematical exploration. The second law introduces the famous formula F equals ma, which shows how the force acting on an object is equal to its mass multiplied by its acceleration. This law not only provides a mathematical description of motion but fundamentally changed the methodology of physics, paving the way for future advancements. Lastly, Newton's third law conveys that for every action, there is an equal and opposite reaction. This principle is observable in countless everyday situations, such as when we push against a wall, our body pushing back with an equal force. The influence of these laws cannot be overstated, as they form the cornerstone of classical mechanics, affecting how we perceive everything from flying airplanes to firing rockets. Beyond motion, Newton revolutionized our understanding of gravity. His law of universal gravitation posits that every particle in the universe attracts every other particle. The force of this attraction is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. In a mathematical sense, we express this as F equals g times m1 times m2 over r squared. The story often told of an apple falling from a tree inspiring Newton's inquiries into gravity captures the essence of scientific curiosity. While the tale may be more folklore than history, what remains is the profound realization that the same gravitational force that causes an apple to fall to the ground is also what keeps the moon in orbit around the Earth. This insight represented a monumental shift in our understanding of celestial and terrestrial bodies, illustrating that the universe operates under unified laws. In addition to his pioneering work in physics, Newton made significant strides in mathematics, independently developing calculus, a branch that deals with rates of change and accumulation. At the same time, Gottfried Wilhelm Leibniz was also developing similar ideas, leading to fierce disputes about who truly invented calculus first. Today, both men are acknowledged for their contributions, with the notation we commonly use today credited to Leibniz for its practicality. Newton termed his version the method of flux ions, demonstrating his unique approach to mathematics that combined rigorous logic with observation. This innovation expanded the horizons of science and enabled future generations to grapple with complex problems across various fields. Optics was another area where Newton left a considerable mark. His experiments with prisms revealed that white light comprises a spectrum of colors, leading to the understanding of light as a wave rather than a simple straight line. He built the first reflecting telescope which utilized mirrors instead of lenses to minimize color distortion, a significant advancement over existing telescope designs. His book Optics, published in 1704, was unique in that it was written in English, making it accessible to the general populace, unlike many scientific texts of the time which were penned in Latin. Newton's academic journey took some unusual turns as well. The Great Plague struck England in 1665, prompting Cambridge University to close its doors. During this hiatus, Newton returned to his family's home and embarked on what he referred to as his Annus Mirabilis, or Year of Wonders. During this significant period, he developed his theories on calculus, gravity, and optics, making some of his most important discoveries while working in isolation. Upon returning to Cambridge, Newton was appointed Lucasian Professor of Mathematics at the young age of 26, a prestigious role he held for over 3 decades. His capacity for intellectual inquiry and productivity during such times has made him one of the most celebrated scientists in history. One of Newton's monumental contributions was his work on Kepler's laws of planetary motion. By applying his laws of motion and the law of universal gravitation, Newton derived these laws, demonstrating that the same principles governing objects on Earth also apply to celestial bodies. It was a groundbreaking moment that revealed a universal physics governing both terrestrial and celestial phenomena. Newton mathematically proved that planets operate in elliptical orbits due to the inverse square law of gravity. This unification of principles marked a significant victory for science, illustrating that the universe's mechanics could be understood through a singular framework. Interestingly, Newton was also deeply engrossed in alchemy and theology, spending a great deal of time attempting to transform lead into gold and studying ancient texts for secrets of the cosmos. These pursuits reflect the multidimensional interests of intellectuals in his time. Despite many of these interests being regarded as unscientific today, they were common among the scholars of the 17th century. Newton's devout Christian beliefs led him to write extensively about religion, believing there were hidden messages within the Bible regarding the future of humanity. In his quest for truth, he even calculated the date of Jesus' crucifixion using astronomical observations, a fascinating intersection of faith and science. However, it is worth acknowledging that Newton was known for having a difficult personality. He could be secretive and quarrelsome, often finding himself in disputes with other scientists like Robert Hooke and Gottfried Leibniz. These rivalries, however, didn't overshadow his contributions to society. Newton successfully served as the master of the Royal Mint, where he took a hard stance against counterfeiting and revamped the English currency system, reflecting the seriousness with which he approached all of his endeavors. His legacy is one of remarkable depth. Newton's work on motion and gravity dominated the field of physics for over 2 centuries until the advent of Einstein's theory of relativity. His methodologies laid the groundwork for the Industrial Revolution, initiating rapid advancements in technology and engineering. The impact of Isaac Newton extends beyond his time, forever altering our interpretation of the universe through his pioneering spirit and scientific rigor. In this exploration of Isaac Newton's life and works, we delved into how he laid the foundation for modern physics with his laws of motion and universal gravitation. We examined the critical insights he brought to mathematics with calculus and the significant advancements he made in optics. Additionally, we discussed his cultural context, personal challenges, and the scientific rivalries that shaped his career. Newton's influence continues to echo through time, demonstrating how his quest for knowledge transformed humanity's understanding of the universe. His contributions remind us of the power of curiosity and the profound impact of scientific inquiry. Thank you for joining us on this enlightening journey through the life of Isaac Newton. We hope you gained a deeper appreciation for the contributions of this extraordinary scientist. Remember to subscribe to Spelling Bee Ninja for more fascinating educational content that fuels your curiosity and expands your understanding. Stay curious, keep learning, and until next time, take care.